No day is complete without, doing a ridiculous geometry problem, right? So I thought that we might do this one and then we can call it a day. The area of this triangle, the very biggest one, from A to B to C, is supposed to be 24. And what I've drawn is from C to M being the midpoint of side AB, and then from A to N, with N being the midpoint of side BC. And then I've labeled their intersection point in the middle as point G. And I'd like to know what is the area of the triangle consisting of the points G, M, and N. So the area of that thing in there. This is going to end up depending on some things that you might not see coming. First of all, let's look at the fact that ABC and GMN have a base. Yes, a base that is like kind of similar, like based on the same sort of thing. You'll be familiar with the fact that MN is equal to 1/2 of AC, right? Think about this. It's from the mid-segment theorem. MN is parallel to AC, and MN is equal to 1/2 AC. These two are conclusions that come from the mid-segment theorem. We are specifically going to need the fact that MN is equal to 1/2 AC. We might need to go and grab the parallelism as well. Now, let's think about the fact that, well, yeah, I think we are going to need the parallelism because that's going to be involved in proving that triangle MGN is similar to this triangle down at the bottom. I'm not sure how to label it yet, but let's figure it out. First of all, these two must be the same because of vertical angles, right? We also know that MN and AC are parallel because of the mid-segment theorem. What this tells us is that by alternate interior angles, this angle and this angle are also congruent. Because we've shown that triangles GMN and AGC have two angles in common, that's enough to show that they're similar. Now, let's see. GMN goes single tick mark, double tick mark, or MGN rather, which is what I've written, goes double, single, unlabeled. So double, single, unlabeled for the other would be CGA. Now, I want to know the scale factor. What is the scale factor between the smaller triangle and the larger triangle? Well, let's base it on this. MN is equal to 1/2 AC. That means that the scale factor for the similarity between MGN and CGA has to be 2. So I want you to think about what this means. This means that MG, or the altitude of triangle MGN will be 1/2 the altitude of triangle, oops, I wrote GG, CGA. It'll be 1/2 the altitude of CGA. That means that if we consider the bottom half of the altitude of the entire triangle to be split into two pieces, one of them being up here and the other being down here, then triangle AGC gets 2 of those pieces, and triangle MGN gets 1 of those pieces. So what that means is that altitude of triangle MGN will be 1/3 of 1/2 of the altitude of triangle ABC. Believe it or not, this is enough by itself to solve the problem, because now we're going to put this together with what we know about the comparison between the bases. So MN is 1/2 AC. We know that from the mid-segment theorem, right? Now we also know that the altitude of triangle MGN is equal to 1/6 the altitude of ABC. So if I want to form the area of MGN, I'd be multiplying MN by the altitude of MGN and then timesing that by 1/2. So the area of triangle MGN is going to be equal to 1/2 MN times the altitude of the altitude of triangle MGN. This might not seem like it clinches it, but it really does, because what this can be rewritten as is 1/2 times, and then I'm going to do a little bit of magic here. I'm going to swap out MN with 1/2 AC. And then likewise, I'm going to swap out altitude of MGN with 1/6 the altitude of ABC. Here's what that's going to do. 1/2 times MN, well, now that's going to be times 1/2 AC. Okay, and then altitude of MGN, I'm going to call that 1/6 the altitude of triangle ABC. If you're still in the dark about how this is helpful, don't worry, it's going to get clear real soon. 1/2 times 1/2 times the 6th is 1/4 times the 6th is 1/24. 1/24 times AC times the altitude of triangle ABC. And this might be more helpful to write as this: 1/2 times 1/2 times AC times altitude of triangle ABC. Because what I want you to notice here is, I'll get rid of some of this to give me some room. What I want you to notice here is that this quantity here is, oops, I wrote 1/2. I should have written 1/12. Sorry, because 1/2 times 1/12, that would be 1/24. That quantity there that I've bracketed in red, that is that if the 12th is written on the outside, that's where I want it. Now, the thing that's bracketed in red, 1/2 times this base right here times this altitude. What is that? Pause, think about it. The altitude of ABC times AC times 1/2. This is the area of triangle ABC. Remember that math problems always involve taking, like, knowns and linking them with unknowns. So we had this unknown quantity, the area of MGN, and now we've finally formed a relationship to something that we did know from the start, the area of ABC. So this is going to be equal to 1/12 times, what was the area of ABC? We knew it was 24. So 1/12 times 24, and that is equal to 2. So believe it or not, starting from very little information, you can find the area of that triangle right there in the middle. Cool, huh?